Hello students, welcome back. We did some standard normal problems, but we were doing just forward problems. Kind of like these. When z value is there, what is the probability? We did those kind of problems. Now, let's go backward. When the probability is given, estimate your z value. Okay, here's the first problem. And the probability is about 0.25. What does that mean? Well, let's open up the drawing mode. So we get this kind of normal picture, centered at 0. And then the shading is 0.25, but you see, left-hand side shading is 0.25. So if you draw something here, and then left-hand side will be much bigger. So you have to draw something here so that this is about a quarter. It should be a little bit bigger, I guess. And this is the value that I'm interested in. And then this probability or this area is about 0.25. I mean, it's very difficult to draw numbers. I can write easily, but drawing. Anyway, if shading is 0.25 and I'm looking for z value, that's what you're doing. Now, if you go over to the normal table, then you can find out the probability with z-score of the first two decimal digits, first column, and then get appropriate row, and then the second decimal digit. But this time, excuse me, this time we have to go backward. All right, let's get out of this drawing mode now. And then here's the normal table. But let's see, where's 0.25? We have all these numbers. And in the first page, we have up to 0.5. And then here, bigger than 0.5. So 0.25 must be somewhere in the first page. This area has to be about a quarter. 0.25. Where is 0.25? Probably you won't be able to find it precisely, so you'll have to do some estimation. 0.25. I have it right here. So 0.2514 and then 0.2483. 0.25 will be somewhere in the middle. Does it make sense? Negative 0.6 and then 789. So this is 7 column and this is 8 column. So negative 0.6, 7, and negative 0.68, somewhere in the middle. So my estimation is negative 0.67 and then about 5 because you see 0.0014 and 0.0017 very close. I mean very close. So somewhere in the middle will be my estimation. So that is my estimation for my z-score here. Of course, this is a rough estimation, and you can use anything in between 0.67 and 0.68. I just estimated as negative 0.675. Let's check. Let's go back to my notebook and let's check. Negative 0.67449 according to Mathematical's computation. Hey, that was very good estimation I did. Negative 0.675 is what I got. And I'm really happy because this came really close. So that's what we do in inverse problem. Here's another problem. Z is greater than a certain small z value, but the probability is supposed to be 0.325. How do you deal with that? Well, okay, all right, 0.325. Okay, all right. Let's open up this normal table. Where is 0.325? It's got to be somewhere around here. 0.3264 and 0.3228. So 0.325, so somewhere in between. So negative 0.4, and this is 0, 1, 2, 3, 4, 5 column, and this is 6 column, 7, 8, 9, all right. Somewhere in the middle, 0.3264, 0.3228. Again, pretty close. So negative 0.455. That's my estimation. What do you think? Is everything okay? Is everything good? Negative 0.455? Well, you see, I have to get out of this drawing mode and I'm going to lose all this. So that's why I'm asking a question now here. Check everything and see if this is correct. Negative 0.455. Is that right? Actually, no. Let's get out of this drawing mode. So right here, so negative 0.455, that looks okay, but why is it wrong? That's because this is left-hand side shading, and I want greater than the right-hand side shading. You see, if you don't draw the picture, you can make this kind of mistake. So 0.325 is the right-hand side shading because I have this random variable greater than that z value. So what you should have looked at is 0.675. And if you look up your z-score, z table, and do it right, you're going to get about z value approximately equal to positive 0.455. Wait a minute. Previously, we had negative 0.455, and then go over there, we have positive 0.455. Yes, indeed. As a matter of fact, that's because of the symmetry. So if you screw up left and right, you don't really have to redo. All you have to do is to change the sign. As a matter of fact, let's actually check if this is correct. So yes, positive 0.4537. So 454 versus 455. Again, pretty good estimate. There was plus and minus issue, but that was actually an intentional mistake. I made a mistake intentionally so that I wanted you to think about it. And I'm going to do that a lot. I have done it a lot too already. How about something like this? Between 0 and z is 0.275. So this part is 0.275, the red part, between 0 and z. So if you're going to look up the normal table, you need left-hand side shading, and this left-hand side is of course half, so 0.5. So you have to look up 0.775. So find out your z-score from your z table, the closest to the probability for 0.775, and you're supposed to get about something like this, 0.755. Yeah, okay, all right. I'll leave you there. And then here's another one. From negative z to positive z is 0.95. What is that? It's a negative z to positive z. Middle part is 0.95. That means here we have 0.025 and there we have 0.025 because of the symmetry. So what do we have to look up? For this z value, 0.95 and 0.025, so you have to look up. And z value closest to, the probability value closest to 0.975. So you have to look up probability that capital Z is less than or equal to small z is approximately equal to 0.975. Does it make sense? 0.95 plus 0.025, and that's 0.975. So 0.95 is a middle part, that's red, and 0.025 is the left-hand side, that blue. So you have to look up 0.975 from your normal table. Well, if you go ahead and look it up, 0.975, where is it? Right here, 0.975, it's 1.96. 1.95996. Okay, 1.96 is good enough. Z is approximately equal to 1.96. Oops. Again, all those are area problems. The details are left to the students.